Good morning, everybody. So today we will continue the Aeolian processes and the landform produced by the wind activity. Previously, in the previous class, we came to know about the erosional processes done by wind and the wind-blown particles and the different kinds of landforms. Now, if we try to just get a brief idea about the previous class, we came to know that particles, that means sedimentary particles, which are carried by wind during the transportation, they becomes well rounded during their transportation because of their repeated impact with each other, as well as their impact with the exposed rock in the earth's surface. So for this repeated impact, repeated collision between the grains, the sedimentary wind-blown particles becomes well-rounded and well-sorted. And not only that, sometimes if we look the wind-blown particles more closely with the help of some lens, we can see some frosted appearance of the surfaces of the particles. Now, frosted appearance means the surface of the grains looks glassy like a mirror. And that happens due to repeated collision, due to repeated impact of grains between each other. The outcrops of rocks in arid regions undergo the greatest amount of erosion close to their base, because we know that most of the wind-blown particles, particularly the sand-sized particles, they are transported close to the ground surface. Mostly they reach up to 1 meter or few feet from the ground surface. So thereby the exposed rock surface very close to the ground, they are facing most impact event by the moving sand grains, and thereby erosion and weathering of those particular portions of the rock are more found to occur compared to the other portions of the exposed rock. Now, if we look at the transportation process of wind-blown particles, mainly the wind-blown particles moved in three different ways. Particularly the sand-sized particles, they are moving either by rolling along the surface or by saltation, that is periodical jumping along the surface. So occasionally they came into contact with the ground surface. So in this way, mainly the coarser fragments, that is the sand grains, they are moving along the moving air into the bottom wind direction. In contrast, the finer size fragments, that is the silt and clay size particles, they are easily lifted by the flowing wind, and they are taken higher part of the um, wind or moving air, and mostly they are moving in turbulent condition, and as suspension load they move with the wind. Now, apart from these three, that is the bed load, saltation, and suspension load, it was found that at sometimes the particles are moved by some different way. That way is known as creep. What happens in creep, that whenever a sand grain is moving in saltation, so it periodically goes into the air, and after some time comes back to the surface. So in this jumping way, it moves in the forward direction. Now when this jumping sedimentary grain, if you consider this grain, came into contact with the surface, with the earth's surface, if it hits another grain, then although that particular grain is in a static condition, but due to the impact of this grain, that particular grain will move few inches or very minute distance into the forward direction, into the downwind direction. Although it occurs in a very uh, negligible distance, this static particle move a very negligible distance, but that kind of movement due to the impact of this falling grain are often observed in a moving air. This kind of movement of sedimentary particles is known as creep. Now coming to the deposition by wind. So in a moving air which contains lots of detrital particles, lots of sediments within it, and we came to know already that most of the particles within a moving air are below sand size particles. Now when does from these blowing or moving sedimentary particles come into rest, that means deposition from wind occurs, is due to reduction in velocity. That means the moving air loses its energy, lose its kinetic energy, and thereby now the moving air is not able to carry the sedimentary particles further in the downwind direction. So thereby, due to the reduction of energy condition, due to the reduction of velocity, the carried sedimentary particles are deposited over the earth's surface. Second cause by which deposition from wind can occur is due to the any kind of obstruction to wind. Now whenever wind blow in the downwind direction, in some particular direction, uh, it was found that in case of wind, most of the portions of the wind are flowing by turbulent flow. So there is a random admixture of air molecules along with the wind-blown sediments. Now, when during its flow path, if there is a restriction like this large size boulder, if it blocks the movement of wind, so immediately the wind hit the upwind direction or up current direction, and they try to diverge the restriction. So all the upcurrent direction of the restricted body, they will face the direct impact of the uh, flowing wind. So in this surface, in this upcurrent surface, the impact of wind-blown particles occurs, and all the ventifact surfaces are formed in this surface of the boulder. So this surface suffers erosion. But in contrast, the opposite side, that is the down current side or downwind uh, flow side, in this side, this portion does not feel any effect of the blowing wind. So that is why this portion is known as shadow zone, because energy in this portion of wind is almost negligible. So the wind in this portion of the uh, restricted body, that is the windward down current portion of the restricted body, that blocks the flow energy of the moving air. So thereby the wind in this portion, that means the atmospheric molecules in this portion, they are almost static in condition. So thereby they does not have much energy, because this body acts as a barrier. So any wind falls in this direction or go in this direction, they does not feel the moving energy, and thereby the kinetic energy suddenly drops in this uh, place. So deposition occurs in this shadow zone. So you can see often that in the down current direction of any moving wind, if there is any restriction body, often a tail of sedimentary deposition found in the down current direction, and that tail occurs in the shadow zone because energy reduced in energy condition deposition occurs. So if you look, if you find a barrier body, a barrier rock or a barrier boulder along the journey path of a moving air, you can see that the upwind direction is the erosional surface, whereas the downwind direction, the deposition of wind blown particles occurs. Now here, reduction of energy, reduction of wind velocity occurs in this shadow zone because of this presence of obstruction. The last cause due to which deposition from moving air occurs is due to certain increase of load. That means if by any chance the sedimentary particles which are carried by moving air into the down current direction, the amount of sedimentary particles will increase into the certain uh, moving air. Then due to the increased amount of load, due to the increased amount of detrital sedimentary particles, the wind does not carry, the wind is not able to carry all those detrital particles. So that causes deposition of some sediments. And this time the deposition occurs due to some way increase of sedimentary load. So these are the three causes for which deposition from a moving air occurs. Now, in a dry area, often we found these kinds of storms. These are called dust storms. If it is found that most of the windblown particles are of silt to clay sized particles, but often in a high energy moving air we call them as sandstorms because in that case the windblown particles are mostly of sand sized particles. So depending on the sedimentary grain size blowing by the wind, the name of the storm varies. If it is blow mostly the silt and clay sized particles, it is known as dust storms. If it is blowing mostly the sand sized particles, it is known as sandstorms. But if you look at more closely to this picture, you can see the bottommost portion is more dense, is more dark. This indicates that these sediments are coarser than the topmost sediments. The top portion sediments are mostly very fine. These are sealed to clay sized particles. So they spread a much larger area compared to the bottom sediments. You can see the areal spread of this bottom portion is narrow compared to the upper air. The upper air spread of sedimentary particles is far greater than the bottom portion. So this occurs due to the relative size of the wind-blown particles. We already aware that the sand grains, that is the coarser fragments of wind-blown particles, they are mostly restricted within the few feet from the ground surface. So you can also see that in this portion, these are the coarser fragments, and as we move up through the air and observe more precisely to this storm event, to this blowing wind, you can see that the density of uh, the wind-blown particles gradually decreases. That means the wind-blown particles now dispersed in a larger area, and that occurs due to their lower grain size, and that becomes due to the lower grain size, the grains are easily floating within the air and they cover a much wider area. Now when the wind-blown particles, that is particularly the silt and clay-sized particles, they are moving in the higher level of the or higher part of the uh, atmosphere, higher part of the moving air. uh, we found that they result in dust storm. Now, when from these dust storm deposition of this suspended load occurs, they form a homogeneous, almost non-stratified. That means no layering found within this deposition. And as those are very well sorted, that means a particular grain size is carried at that condition through suspension. So deposition of those sediments makes the deposition very porous. That means there are lots of open spaces, lots of void spaces between the or within the grains. So when the suspended load deposition occurs, the deposition is a massive unit, and almost there is no layering, there is no stratification. It is highly porous, and this kind of deposition unit, you can see in this picture also, that this entire picture, in this picture you will not easily identify any kinds of layering. It's almost a homogeneous unit. There is no layering, there is no almost no size differentiation of the sediments. This kind of deposition is known as loess, and these are of mainly occur due to the deposition of suspended load from wind, that is mostly of silt and clay sized particles. Now, the thickest known lowest deposit found in the lowest plateau of China, which is about 335 meter in thickness. So this vertical thickness is about 335 meter. The second and most common uh, deposition found in Aeolian condition, that is known as sand dune. The sand dunes are simply the wind-blown sand particles deposited, and they formed some characteristic undulating surfaces in which one side is gentle. You can see in this picture, this side is gentle, that is lowly inclined, whereas the other side is relatively steep, that is highly inclined. Now the gentle side is known as the stoss side, whereas the steep side is known as the lee side. And you can see in most of the cases the dunes are asymmetric in nature. Always the stoss side is greater than lee side. It will never happen that lee side is greater than stoss side. It will never happen. The stoss side is greater than lee side for an asymmetric ripple. And if we for an asymmetric dune, and if we found this kind of asymmetric dunes where stoss side is greater than lee side, we can easily interpret the flow direction. The flow direction is always from stoss side to lee side. That is, for this particular direction picture, the flow direction is from left to right. Now, if this kind of feature found in the earth surface, then with moving air, the stoss side will face the moving air and the windblown particles. So the stoss side becomes eroded, and the eroded particles are deposited in the lee side. So always the stoss side face the erosion effect, and the deposition occurs in the lee side. So wind in this way, due to some erosion and deposition activity of wind along the two surfaces of a dune, the dune gradually moves forward or gradually moves in the down current direction of the moving air. So when this is the position of the dune, the wind-blown particles hit the stoss side, erosion occurs. Now the modified stoss side will be like this, and when deposition occurs in the lee side will move forward. So in this way, erosion occurs from stock side and lee side grow in the down current direction. Now dunes are of variously shaped deposit that depends on the direction of wind as well as the sedimentary grain size particles. So supply of wind grain size as well as the direction of wind flow controls the different kinds of shape, the different varieties of dunes. Alps are the huge dune fields. They cover about one-fourth to one-third of the area of the true desert. So whenever we heard the term desert, the first thing came into our mind is these kinds of huge undulating surfaces, which we came to know that they are known as dunes. But the desert is not solely made by these kinds of dunes. In a desert, about one-third to one-fourth portion is only composed of these kinds of dune fields. In the peripheral part of these dune fields of desert area, there we found some gently undulating sandy surfaces. That sandy surfaces almost creates almost found like a apron or sheet like occurrence. In this picture you can see. So these are the dunes in the central portion, and the peripheral part, this part, here you can see a sheet of sand is spreading in this portion with minute undulations. These are called sand seeds. Sand seeds are formed on borders of desert having a scanty vegetation. So generally in this sand sheet portion, that is the peripheral part of the dunes, we found some scanty vegetation cover. Now, as I already told you that dune types are related to the variability of wind direction as well as the amount of sediment supply, particularly the sand supply. Now, here you can see in the x-axis, wind direction variability is drawn, where close to the origin you can see unimodal wind flow direction, and as we move more positive side of the x-axis we found more and more complex wind flow directions. In the y-axis, as we move in the positive side of the y-axis from origin, we can see the sand supply will increase. Now depending on the two parameters, if we plot all the different kinds of dune forms found in nature, we can see that when the wind direction variability is very poor, that means almost there is a unimodal flow direction of wind, and the sand supply is very poor, Barkhan type of dunes are formed. With unimodal direction but higher amount of sand supply, transverse dunes formed. With more complex wind direction, that means wind will flow from various directions, and lower amount of sand supply, network of dunes formed. Higher sand supply and various wind blow directions, star dunes are formed, and moderate sand supply with moderate variation of wind direction, linear dunes are formed. So you can see that the dune forms are changing in a sharp way with variation in wind direction as well as the amount of sand supply. So with the same direction of wind, simply by changing the amount of sand supply, you can get different types of dune forms. Similarly, with same amount of sand supply, with changing in wind direction, uh, we can get various types of dune forms. Now coming to the details of the various kinds of dune forms. First type is the Barkhandu. These are asymmetric crescent-shaped dunes with its tips, these pointed tips, which are also known as horns. They are pointing towards the down current on downwind direction. In other way, you can see that this upwind direction is a broad arc and it is convex in nature, whereas the downwind portion, this portion is of concave nature. So you can also say that the convex side of the Barkhandu is facing the upwind direction, whereas the concave side of the Barkhandu facing the downwind direction. Or the flow direction can be also identified by observing the horns, which are facing always in the downwind or downcurrent direction. Now these kinds of winds, as we already see in the previous picture, they are formed mainly for unidirectional flow with a low amount of sand supply. The height of these kinds of dunes can reach often about 30 meters from the ground surface. The second type of dunes is known as transverse dunes. These kinds of dunes forms with unidirectional flow, but in this case, the amount of sand supply is very high. The dunes are oriented or elongated perpendicular to the prevailing wind direction. That is, these high level points, which are known as the crest points, and when successive crest points are joined by a line, the line is known as crest line. That is basically the demarcating portion of stoss side or and lee side. So this is the crest point. Now this is the most carved portion of a dune, this portion. Now the crest line orientation of the transverse dunes is always perpendicular to the flow direction. From the prevailing winds, which are steady, and that means which are unidirectional, and when there is an abundant amount of sand supply, these kinds of transverse dunes are found to occur in nature. The next type is longitudinal dune. As we already came to know that in this case, the wind direction variability is moderate, as well as the sand supply is also moderate. Now, the longitudinal dunes are often look like the sword of the Arabian peoples. Now, in Arab countries, the sword is known as sif. So from that, as it is, these kinds of dunes are looked like the sword of Arabian people with straight ridges. The longitudinal dunes are also known as sif dunes. Now these dunes have elongate parallel to the prevailing wind direction, elongate ridges. The sif dunes are long, narrow, sharp crested, and they are commonly found in the desert of Sahara. Now these dunes are formed when the wind direction variable is mainly coming from two sides, and they meet or coalesce each other with a narrow angle. So due to the coalescence of these two different directional winds, when they converge, when they meet with each other, they formed a these kinds of narrow ridges dunes as you see in this picture also, and that produce the sheaf dunes. The sides of these sheaf dunes, the two sides, this side and this side of sheaf dunes, are steeply inclined at about 25-degree to 30-degree angle they make with the horizontal surface. The next type is known as star dune, where the variation of wind blow direction is highly varied. Wind comes from various directions. As you can see by these arrows, wind is flowing through various directions, and the amount of sand supply in this case also is very high. Now, from top, you can see that the crest lines are often found to occur that they are diverging from a common point. So you can see that from this point it appears that this crest line goes in this direction, this is going this direction, this crest line goes in this direction. So you can see that the crest lines, they appear that they are diverging from a common point almost like a star. So from that, these kinds of dunes are known as or named as star dunes. Now, in the coastal area also, which is not so dry, because in the coastal areas they feel the effect of the marine water activity, and there is lots of moisture in the atmosphere. So in those areas, sometimes dunes are also found to occur, and these dunes are known as coastal dunes. Now, as we already came to know that the activity of wind is mostly found in a dry condition, but the coastal area is not so dry. So these dunes are genetically and morphologically different from the dunes formed in a arid to semi-arid conditions. And the most readily identifiable difference found to found in the coastal dunes, that these dunes, they do not migrate with the moving air. That means these coastal dunes are almost static in their position, and they occur parallel to the coastline. Now, the coastal dunes form when there is a large supply of beach sand by the wave activity of ocean. So ocean waves, they deposited huge amount of sand into the beach areas. Now the onshore wind, that is the wind coming from the sea towards the land, they will push or drag those sand which are deposited in the beach area towards land areas. And in the land areas where there is a uh, ample amount of vegetation cover is there, these moving sand are stuck within the vegetation cover, and they form some linear ridges of dunes parallel to the shoreline. So often the coastal dunes are found to occur parallel to the shoreline, and particularly the coastal dunes are found to occur where the beach area is very wide. In a narrow beach, these kinds of dunes cannot form because wind have to play a sufficient role to move the beach sand to the more landward part. These are known as coastal dunes. Now, often the coastal dunes are later modified and they form the parabolic dunes. Now, these parabolic dunes are also crescent shaped and they look very close or very similar to the Barkhandu's. But the sense of flow in these parabolic dunes is opposite to the Barkhandu's. In case of Barkhan dunes, we can see that in this crescent shape, the convex side facing the upwind direction and the concave side facing the downwind direction. That is in case of Barkhan dunes. But in case of parabolic dune, the concave side is facing the upwind direction and the convex side facing the downwind direction. Also, the horns, the pointed tips of the crescent shaped dunes, in case of parabolic dunes, they are always facing the upwind direction. Now, these kinds of parabolic dunes are also found or also the modified forms of coastal dunes. Now, these forms, when wind cause the blowouts of sand resulting in a crescent shape. So what happens, in the coastal dunes, there are some scanty vegetation occurs here and there. So you can see here are some vegetation occurring, here are some vegetation occurring. So sparse vegetation are there. Now in this sparse portion with the vegetation, the sand grains deposited here, they are more static, they are more uh, fixed in their place. Now when moving towards the onshore area, that is from ocean to the land area, they are not able to push the coastal dune sands more landward in this portion, that is those portions which are associated with vegetation. but in between the vegetation cover, there the wind found some sand grains which they push more landward side, and that makes the dunes to form these kinds of crescent shape. So these are the modified versions of the coastal dunes. Now, due to the pushing of the particular portions of the coastal dunes, here you can see the arms are found in these crescent shaped uh, dunes, and these arms and their pointed tip, the horns, they lagged behind. They remained in their original positions, and they will indicate the original position of the dunes, as well as they will face the upwind direction of the prevailing flow or prevailing wind flow. Now, apart from these, the dunes can be classified on the basis of whether they are fixed to a certain place or they are continuously moving. Now, in this case, sorry, this was a mistype here. This is called free dune. So these are the different types of free dunes. And within free dunes, these are various types. The transverse dunes, where the crest lines are oriented with a perpendicular direction of the prevailing wind flow directions. The Barkhanoid, these are the modified versions of transverse dunes, where you can see the crest lines are somewhat more sinus in nature. So these are the one kind of transverse dunes, but you can see the crest lines of the dunes are more sinus in nature. The Barkhan dunes, the isolated crescent-shaped dunes in which the horns always pointing the downwind direction. The dome-shaped dunes, these are the heap of sand grains or the mount of sand grains piled in one places. These are called dome. The star dunes, which forms due to variable wind direction, and it appears that all the crest lines are diverging from a common point, and that makes or that looks the shape of the dunes as a star shaped. From that star dune name is given. The linear dunes, when the prevailing wind flowing is mostly from two directions, and when they converge, when they coalesce with each other, they form these kinds of narrow rigid dunes, which are known as longitudinal dunes, linear dunes, or shift dunes. The other type of dune is known as fixed dune. Sorry, here again mistyping occur. This is actually fixed dune. Now, in this fixed dune, the dune position after its formation is always fixed. It will not move with the moving air. Now, what are the different kinds of fixed dunes? The first is dunes around an obstacle. So, whenever a moving air found a obstacles, some kinds of deposition found to occur swirling around the obstacle. These kinds of dunes are also known as fore dunes, and often we found that there is a double lee tail of the dunes, two tail of the dunes encircling or found on two sides of the obstacles. So by observing these lees opening, uh, we can also interpret the moving direction of the air. Second is the single lee dune that happens again due to an obstacle in which the moving air face the restriction and deposition occurs in the downwind direction. That is a tail of sand deposition. So here the dune is known as lee dune. The third type is known as climbing, falling, and eco dunes. Now these dunes is particularly formed where there is a restriction having a large area. Now the climbing dune, falling dune, and eco dune, they are formed depending upon the slope of the obstacle. When the upwind slope, this slope of the obstacle is less than around 30°, the sand blows over it. There will be no deposition in this portion, in this upwind direction. But this portion in the downwind direction, as this was a shadow zone, here deposition occurs, and this is known as falling dune. But when the slope of the obstacle is above 30°, then sand is trapped in this upwind portion of the obstacle, and then it forms like a ramp from which you can climb on those obstacle. So then these kinds of dune is formed, climbing dune. So below 30° slope there will be no climbing dune, there is falling dune. Above 30° slope in the upwind direction of the obstacle, there will form climbing dune as well as falling dune in the downwind direction or downwind part of the obstacle. But when the slope of the obstacle is exceeding 50°, then an echo dune formed in the upwind part of the obstacles, and that is a few uh, unit or few distance away from the original obstacle. So this forms as a echo or replica of the original obstacle. So that is why these kinds of dunes are known as echo dunes. Now, echo dunes only formed when the slope angle of the obstacle is above 50°. The fourth type is known as lunate dune, when there is a little wet surface having some moisture, having some water in the ground, then wind deposition or sand deposition from the moving air found to occur around the wet surface. These kinds of dunes are known as lunate dunes. Now, one interesting thing is that these are almost close in appearance like the Barkhandu dunes or parabolic dunes, but these are not parabolic dunes, because parabolic dunes is occurs only in the coastal areas. And again, this is not Barkhandu dunes, because Barkhandu dunes is free to move, they are changing their position with the moving air. But the lunate dunes, they are always fixed in their positions. And not only that, Barkhan dunes always occurs in dry sand, but lunate dunes are found to occur with these kinds of occurrence of moist surfaces. The fifth type of fixed dune is known as nabkha, or often it is known as nebkha. These are formed surrounding a vegetated landmass. Here you can see lots of vegetation, lots of plants, and the dunes occur from the deposition of moving air surrounding the vegetative landmass. These kinds of dunes are known as nabkha or nebkha. And the last type is known as parabolic dunes, which are occurring in the coastal area, and these forms due to blowout of certain parts of the parallel ridges, straight ridges, coastal dunes, and that makes the dunes somewhat crescent in shape. So these are the different types of fixed dunes, that is, they are not changing their position with the moving air. Now, apart from dunes, in the Aeolian condition, we often found the miniature version of the dunes. That means they are also asymmetric in nature. They are also having a stoss side and lee side, and stoss side is the erosional side, whereas lee side is the depositional side. But their size is much lower than the dune. Mostly they are found having few inches or few centimeters in height. Many of the ripples or ripple marks, they are formed in the Aeolian condition due to some crosswinds, that is not due to the prevailing wind, which is the major wind flow direction, but these are the minor wind flow which are moving from a different direction. So we often found in the Aeolian condition that above the large dunes, these miniature undulatory surfaces are found to occur. and these particularly formed when the energy condition of the wind is relatively low. So with higher energy, higher amount of sediment size, higher sediment supply, it forms dune. With lower energy, lower sediment size, and lower sediment supply, it forms ripple mass. The next deposition landforms, particularly found in the rocky desert area. Now, as I already told, the first impression came to our mind whenever we heard the term desert, that it is an area where lots of sand and depositions are found. But as I already told in the previous class, that desert is not only the place where there is lots of sand, but it is the place where the evapotranspiration loss is much higher than precipitation. That may be a rocky area also, like this one. So here you can see it is a rocky area, not a sand area like the dune fields having the dunes or ripple mass, but instead this is a rock mass where the condition is very dry, where precipitation is very low. But in these rocky areas, when there was occasional rainfall, now as the rainfall is very occasional, so there was no permanent channel through which the rainwater will flow along the downslope direction. But when precipitation occurs, rainfall occurs occasionally, then some temporary channels forms in these rocky deserts, and these temporary channels are known as wadi. Now, when the temporary flow due to the occasional rainfall occurs through these wadis, it forms like a, or it flows like a flash flood. So it takes all the materials along its journey. So rapidly the water flows through the temporary channels, and all the materials in its journey path, they are carried along with it. And whenever the this flowing water, that means the wadi, they intercept with a flat land area, at a glance or suddenly they will deposit all the materials in a fan shaped pattern, like the alluvial fan for a sensu stricto river. Now, as these alluvial fans particularly found for wadi deposits, that they are occasional in nature, so most of the times of the year they are open for Aeolian activity to occur. When there was occasional rainfall, then only the temporary flow occurs through the channels, and they will deposit a ill-sorted mixture of sediments in the flat land areas or in the downhill areas of the mountainous portions. These are also fan in shaped, that is, they are sparsed in a fan shaped with its apex and toe, and they are also known as alluvial fan. And when successive alluvial fans spatially sidewise grow, that as this growing occurs because the channel is not permanent, so during one time of precipitation the channel flows in this direction. Maybe in the next year precipitation, when the water flows through some channels, it will change its pre-existing channel and flow through another temporary channel. So new alluvial fan deposition occurs then. So by this, the lateral growth of alluvial fan occurs, and it almost make a apron of alluvial fan sediments joining all the lateral alluvial fans. These kinds of coalescence of alluvial fans and looks like a apron of alluvial fan deposits in a arid and semi-arid conditions is known as bajada. Now, often it is found after the alluvial fans, the wadi, that is the temporary river in the desert area, they will encounter a flat lying area where the flowing water becomes stagnant, because most of the cases the surrounding areas are highland areas. So in this flatland area, the Wadi river water becomes stored or stagnant. So occasional lake found to occur here. But as it is the dry area, so rate of evaporation will be much higher. So readily the stored water evaporates due to this high hot condition and dryness of the air. So this flatland areas, because of the higher rate of evaporation, the water molecules will vaporize and go into the atmosphere, but the dissolved salt within this water, they will be precipitated, and mostly they are salt, sodium chloride, or different kinds of salt, which are commonly known as evaporites. So we can see the deposition of evaporites in this white like manner, white colored deposition in these flatland areas. Now, this white color deposition when occurs in the flatland areas, so often they are found that they looks very similar to the modern day beaches, that is the coastal areas. And in Spanish, playa means beach. So from that, as these flatland areas in the arid conditions, after the evaporation of water and deposition of evaporites, they looks like the modern day beach area. From Spanish terminology, playa name is introduced, and these areas are known as playa lake or simply playa. And these are the areas where thin evaporite deposit, thin salt deposits are often found to occur. But the most of the cases or most of the times of the year, these lakes remain dry. Only when there is a occasional rainfall in these dry mountainous areas, occasional or temporary channels forms, those are the wadis. They will carry lots of sediments deposited in the foothills, the alluvial fans, and in the frontal part of the alluvial fan in the flatland area, the playa lakes and the evaporite deposition occurs. Now, if you look at the desert and adjacent regions, so desert are the regions of arid climate, very dry condition where there is almost no precipitation throughout the year or very low precipitation, but loss of water through evapotranspiration is very high. The peripheral part of the desert area or the peripheral part of the arid climate, they are not so arid, so they are known as semi-arid condition or semi-arid climate, and these areas are known as stipe. The stipe biome is dry, but they are cold, and there we found lots of grassland. There is not much humidity in the air because stipe is located away from the ocean and close to the mountain barriers. Now, in conclusion to the Aeolian processes and landforms, we can say that wind may erode, transport, and deposit materials, and they are one of the effective agents, particularly in regions with sparse vegetation. Deflation and abrasion are the two methods by which wind carries out most of the erosional activities along the Earth's surface. The erosional landforms produced by the wind activity are the mushroom table rock or pedestal rock, zeugen, earthen, ventifact surfaces, and often by observing the features, we can get an idea about the broad wind flow direction. Wind transportation takes place through suspension, saltation, and creeping. And if you look at the size differentiation, then most of the silt and clay size particles, they are moved up through the air by suspension, whereas the sand size particles, they are restricted mostly in the few feet distance from the surface, and they move either by saltation or by creeping. When deposition of wind-borne particles occurs, the most characteristic deposition landforms are the dunes, the lowest deposits, the sand ripples. Sand dunes form in environments that favors the deposition of sands, and depending on the wind flow direction, or particularly the variation in wind flow direction and the amount of sand supply, different kinds of dune forms, dune morphologies are found to occur. Some are Barkhan in shape, crescent in shaped, some are transverse in nature, some are parabolic, and some are longitudinal. And when the prevailing wind direction is from different sides and varies in a lot, then we found star-shaped dunes. But one thing is very important for the Aeolian condition, that wind deposition is found to occur in almost every place of the world, and wind deposition or wind transportation, that means wind can blow the particles a long distance. Almost sometimes they will cover an entire continent, an entire ocean. After that, their deposition will found to occur. So wind can carry the sediments a longer distance, and deposition occurs. Although the amount of deposition vary from place to place, but wind deposition are found to occur in almost every part of the world. So that's a brief idea about the Aeolian processes and the landform produced by it. Thank you.